Alright, this is Coach Kill here. Just want to welcome to the first installment of Coach Kill's Kitchen. As we've been talking about in class, we've kind of introduced biochemistry, biomolecules, organic chemistry. We talked about the fact that it's all based upon carbon compounds. We talked about the fact that we're going to spend time talking about 4 molecules: carbohydrates, lipids, proteins, and nucleic acids. The first of which tonight we're going to focus on are carbohydrates. Now, we also discussed in class that carbohydrates are probably one of the most important molecules as far as keeping us alive and giving us the energy that we need to do the things that we do. But at the same time, if taking it in too much each time we eat can become a problem, and is one of the leading reasons why we have health issues in this country. But let's focus kind of on the science of carbohydrates. The name carbohydrate literally has hydro in it, has that water component in it. So the name literally means hydrated carbons. So water, like we talked about in class as well, is going to be a huge part of how we use carbohydrates, how we break them down, and how we store them. When we're starting to talk about carbohydrates, a lot of things come to mind. As we look in here in the pantry, we've got things like, we've got syrup is one, we've got chocolate bars is another, we've got things like dried cranberries and any type of fruit. We've got things like short grain brown rice. There's a lot we could do here. We've got cereals, we've got crackers, and probably one of the biggest ones that we think about when we think about carbohydrates is going to be breads. Now, carbohydrates are pretty much anywhere and everywhere. They're in the fruit juices that we drink, which we don't keep a lot here, but at the same time we've got a little Ocean Spray Cranberry Pomegranate Juice Light. This still has, in one serving, which is 8 ounces, 13 grams of carbs. Carbohydrates are also going to be found in the fruits that we eat, and another big time source of the candies that we eat as well. Now, let's take a look at some basic facts here. Like I said, carbohydrates literally mean hydrated carbon. This idea that we talked about in class of water becoming very important. Matter of fact, in the formulas that we're going to see when we come to writing them with carbohydrates, there's always going to be a 2-to-1 hydrogen to carbon ratio. For instance, the formula for a basic sugar is C6H12O6, and you can see here twice the number of hydrogens as carbons. Now, 2 terms that we've got to know when we talk about these molecules. One of those terms is monomer, and another one of those terms is polymer. A monomer, like I said in class, is kind of like the building block. It's like the single Lego in the entire box that you have that then you're going to use to build things with. When you talk about carbohydrates, the monomers are going to be what we call monosaccharides. So when you look at the word monosaccharide, you see the prefix mono there. Saccharides referring to the sugar portion. So this literally talks about it being one sugar. Your body can only use 1 sugar molecule at a time. So when you eat a piece of cake, or I eat an apple, or I eat a baked potato, you know, your body's looking at this and saying, you know what, it's sugar. Sugar is sugar is sugar. The sugar here in this apple is no different than the sugar here in this fruit juice, is no different than the sugar that you see over there in the container on the other side of the kitchen that we use to make things like chocolate chip cookies with. The difference is going to be is how many sugars are in each molecule. Monomers in this case are going to be single sugars. Now those sugars are going to come in one of 2 shapes. A 5-sided shape and a 6-sided shape. And I'll show you those in class tomorrow and kind of give you more of a 3D representation. The polymer, kind of the big, if you want to think about best sugars, are what we call polysaccharides. In this case, we're referring to many sugars that are together in one molecule. So instead of giving us one basic small molecule that we burn pretty quickly, now the reason why things like baked potatoes, the energy we get from vegetables, the energy we get from fruits, are going to be now, well, I take that back, fruit's probably not as much, but polysaccharides now that we refer to as starches are going to be now molecules that take longer to break apart, and that's why they're better forms of energy. If we kind of want to think of it this way, if you want to think about some more information, when we look at carbohydrates, we know that their function, number one function, is energy. Okay? They're going to fuel a process in our bodies known as cell respiration. And cell respiration is a chemical process which our body uses the energy to make ATP. And ATP is a molecule we'll get to talking about later. So in this case, number one function of carbohydrates, to give us energy, to fuel us. It's like putting gas in a car. It's like putting new batteries in your Wii remote. And now you've got a fresh set of energy. That energy is going to go into this process, and our bodies can't use carbohydrates directly. That energy of the carbohydrate is now taken and transformed into a molecule we can use known as ATP. And we'll get to, like I said, talking about ATP a little bit later. Now, also discussed in class, what happens when we eat too much sugar at any given time? Well, that's going to get us into what we're going to talk about tomorrow or the next day when we refer to lipids and now being able to store these as fats. In the short term, when you give yourself carbs, you're telling your body, hey, I'm going to give you some fuel to do what you normally do, but I'm also going to give you some fuel for later, for things that you're going to do from sports. And you're going to store this short term in a form that your body takes in and stores known as glycogen. And glycogen is a molecule that is taken out of your bloodstream when you eat too many carbs and is going to be changed into a form that now is put into your liver. And it stays there in your liver for a few hours until you basically tell your body, you know what, I'm not going to use this. And like I said, we're going to get into the kind of transformation of, you know, that carbohydrate into lipids later. Now, looking back in the kitchen, simple sugars, apples, oranges, okay, what we know about those, they have a sugar in them known as fructose, okay? If you were to go to the hospital, you would see somebody on an IV that would be sticking in their arm. And that's basically giving them their nutrients for the day. You'll look on the side of that bag, it'll say glucose solution. Glucose is another simple sugar. So what we do with those simple sugars is we take them and we stick them end to end. And we make now more complex sugars. So you got fructose. Fructose is a monosaccharide, okay? And then you take a molecule like glucose. Glucose is also a monosaccharide, and you put them together. Well, the key thing that you're going to use to put them together is going to be water. And we're going to, like I said, I'm going to show you that tomorrow in class. Also, when you eat big sugars, polysaccharides, and your body uses them, well, like I told you before, they've got to be broken down into individual sugars, individual molecules that your body can use. And that's done with water as well. Like I said, I'll show you that tomorrow with a 3D model. So, you know, when we're talking about using things like sugar, like I said, that we put in our cookies, that we use for baking, and we put in recipes, you know, what makes this sugar different from the sugar that we find in fruits and the sugars that we find that come out of tomatoes, like in my garden in the backyard, that our bodies are going to use? Really, the only difference is number of sugars. Are you talking about a single sugar, monosaccharide? Are you talking about a double sugar, disaccharide, which table sugar is a great example of a disaccharide? Or are you talking about a polysaccharide, a starch? Things that we find in whole wheat pastas, which we have over here. You know, you got to make sure you kind of look at the labels. A lot going on in the pantry here. But when you look at this, certain brands are talking about the fact that not only are we getting carbs here, but we're getting proteins and omega-3 fatty acids, which we'll talk about when we get to lipids as well. But you got great sources of energy here. The brown rices over the white rices. You know, you got to be careful a little bit with the dried fruits because drying them out increases their sugar content. You got to really be careful with the things like the syrups on the pancakes. The pancakes are made out of sugar, basically nothing more than a fried cake. And then you put some Aunt Jemima on it, which if you look at the label on here, high fructose corn syrup and water. So it's really not even maple syrup here. Basically it's brown colored corn syrup, which is, once you think about it, kind of gross. That goes in here as well. When you talk about the brown rices, like I said, if you go to a Payway or PF Chang's, ask for the brown rice. Better source of energy than white rice over a period of time. Once again, those polysaccharides. Cereals, you really got to be watching out for those. You got Special K here. Special K, the serving size is 3/4 cup. You got 12 servings in this box. One serving has 24 grams of sugar. If you look down here, sugar is the third leading ingredient in the cereal. So once again, we think, hey, cinnamon pecan, good source of fiber, good source of whole grains. Got to be real careful. Anything that tastes sweet, anything we usually like, sugar. If you are going to eat the chocolates, dark chocolates are better. They have some antioxidants and some other things like that. So those can be good sources in some cases as a nice treat. You got your crackers, got to be real careful here. Not only are you getting a lot of sugar, a lot of carbohydrates, as you see here. A serving of crackers is 5 crackers. 5 crackers has 13 grams of sugar. Also, you got other things in here where you're not getting a lot of nutritional value. Now, another thing, big time problem for Coach Keel, and that is, for instance, ice cream. And if you hadn't had this ice cream, it's wonderful. Private Selection Denali Caramel Caribou. I'm pretty much an ice cream addict. I told you that in class. 1/2 cup, 25 grams of sugar. Okay, so you take half of your fist, half of your cup-sized fist, and you got 25 grams of sugar. And we're not talking about me usually eating a cup. We're talking about a bowl. So with that, we're going to spend some time now in class. When you get there tomorrow, look at some of the models. Look how water is important to this. Talk a little bit more about why sugar is good, but why we also need to watch out for it. So look forward to seeing you tomorrow. Thank you, and have a good evening.